Good evening, everybody. My name is Cooper Wiegand. I'm a doctoral candidate here at Dakota State University, and as part of my pathway through the cyber operations program, uh, there's a class called CSC 842, Security Tool Development. And so this week I made a new tool. It's called clip2morse, and the goal is I want people to be able to take a video of Morse code, send it through this tool, and it dumps out the Morse code. Morse code's not used a ton in modern day, but I do run into it multiple times a year in CTFs and signal analysis. You might see it if you're like you want to learn Morse, you want to send some back and forth to your friends or whatever. But this is a tool that I've looked for in the past and I haven't found one, so we went ahead and made one. All right, so once you're ready, go ahead and head to the repository on GitHub. It is github.com/cooperw/clip2morse. And we have our README here, but for you, go ahead and hop down to code, clone down this repo however you'd like. And I think what we're going to do is we're going to get our environment set up. I'll show you guys a quick demo, and then for those that are interested, we'll take a deep dive into how we do a couple of the different things that the script does that I think are interesting that I think you'll think are interesting as well. So first things first, get your stuff cloned. I already have it down here in VS Code. So we'll go ahead and follow the README here. Make sure you have Python and Python virtual environments for apt-based systems. You can use this for Mac. You can use brew install Python. Then we'll go ahead and create our virtual environment. You don't have to use virtual environments, but if you want like a no-frills way, you don't want to mess with dependencies, whatever, I recommend it. So go ahead and create our virtual environment here. Let that run, then we'll activate our virtual environment. You'll notice a new VE and V folder up here in your directory. And now once we activate it, you'll notice that we are in our virtual environment. Hop down here and we will install our requirements. All right, so when you're ready, let's go ahead and do our demo. So we'll just copy paste this right here. So we have our environment set up. We're going to use Python, clip2morse. Then you specify your clip. So we'll go ahead and hop in here. And I believe on this system, I have my Pythons split, Python 3. And there we go. Oh, look at that. There's a small error there. Just shows you it runs a little bit different on different systems. So here it's supposed to be SOS, but see how there's a fourth dot in there? So now we get to play with the threshold flag. Let's try 245 is the default. We'll try 244. There we go. Leave it to the live demos to have errors, right? So that's it for the basic portion. Straightforward demo. Put in your clip, turn it to text, whatever. Now we'll take a look at the deep dive stuff of how this actually works and what's going on the back end. For the deep dive portion, let's go back to the README real quick. So there's a troubleshooting thing here, which I want to go through in a second. But right here, we'll come down to our general algorithm. So there's a couple quick steps here, just if you're curious on how this process works. But I'll just I won't read everything. But long story short, what we're going to do is we ingest the video and then we split it into frames. We do a little bit of pre-processing. And then what we do is to affect that jitter that I was talking about, when like the phone moves or maybe there's like a person walking through the background, whatever, we're going to take the first frame as our baseline image and all of this other stuff that isn't related to the flash. So like this right here, this is going to be the same in every frame. That's not useful data to us. So we're going to filter that out. I believe that's somewhere yeah, that's step 2 here. And then we're essentially going to organize all those pixels together. We're going to use k-means clustering to adjust for the delays because different operators are, depending on who's sending the Morse signal, they might send different amounts of gaps. Actually, I believe we have a section on that down here. We'll get in that in a second. And then we use those k-means clusters to essentially um, get our dots, dashes, and word breaks. And then we decode it. The decoding is the easy part, right? So, oh yeah, down here in design challenges. So this is an interesting portion. So something you'll run into is if you are familiar with Morse or things like that, most people know the classic SOS signal. Okay, so when you use SOS, and especially, if you're bringing it here into um, CyberChef, oops, line ending. Um, 3 dots, a space, 3 dashes, a space, and 3 dots is SOS. Okay. But in emergency situations or in the real world, you might encounter something closer to this. And you can see this doesn't quite decode. For example, there's this YouTube video. I'll let you guys click on that. It's a great video for training and things like that. But his SOS signal repeating is something close to this. So we need to do a little bit of extra work on our end to process signals like this for different operators. Maybe he doesn't pause as much between his words or between letters, things like that. So I'll get into that in deeper detail in a minute here. Let's go ahead and rerun our demo. We're going to run it with the basic hack the planet one, but it's going to be the one where the phone moves around a little bit. It's not as clean of a picture. Um, you can see there's like some background data here, like, oh, what's going on down here? Those pixels are changing, you know. So let's take a look at this one. Hop into our VS Code here, and we'll just say Python 3, clip2morse, and we'll say clips, whoops, and it's going to be sample 2. And we're not going to take the cropped version. We're going to take the full, just, you know, I recorded this with my phone and I want to decode it. Okay. So we're going to try using the default one. It says, hey, just so you know, we couldn't locate any pixels above your threshold. You might need to adjust. So our next step, and this is something interesting here. So like I said before, we're going to take all those pixels, right? And we actually give you guys the raw pixels so that you can run your own stuff here. So we'll just kind of take a look here. And you can see what the way that this works here is you have your, at the top, you have your frame number, and you have an R value, a G value, a B value, RBG, right? And then in parentheses, you'll have your number of changed pixels. And these are the number of pixels after we kind of like normalize the photo. When we're talking about like this video right here, we really don't care about this portion of the image, right? But that's all dynamic. We wanted to not have to have the end user have to configure anything. Um, so you can see here, like in the first couple frames, nothing changes, right? It's the beginning of the video. It's probably like some pre-processing stuff. Even right at the beginning here, we're barely moving the camera around. We're pretty steady filming at the beginning here. There's only a 2 pixel difference in frame number 4 from the base frame, right? So when we get down here, we can see that there's a spike almost immediately right here on 38 to 41. So we'll go ahead and separate those out. And there's another spike right here, another spike right here. And you can see when I say spike, I mean there's like 3,000 pixels changing per frame compared to our base frames, okay? And so what that means is you can kind of see here, that almost looks like 3 dots. In fact, I bet you that if we do something like this, we turn on regex filtering, and we do something like 1 through 9, you can almost see in our hack the planet, which hack the planet, by the way, is dot, 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 dash, dash, dot, dash, dot, and so on. Dot, 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 dash, dash, dot, dash, dot, and so on, right? So you can actually see that pattern emerging just right in our thing here. And, you know, our default threshold is 245, but because the camera's moving around, there's a lot of extra data going on. In the thing, what we need to do is we need to reduce our threshold. So we can see there's a pretty definite split here. 236 for this pixel average, or I'm sorry, well, a little bit less than 236, 234, 236, 236, right? So, but it's a lot higher than these 100s. So what we'll do here is we'll simply come back into our command. Go ahead and clear this for you guys here. And we'll just modify our threshold. We'll bring it down to like 200. Okay. Go ahead and let that run. Now we got Hack the Planet. Isn't that cool? So what it's doing now is essentially, um, oh, it modified this. I was like, there's no way that ran. Okay. Um, so that's how you use the threshold thing. I thought you guys would think that's interesting. So we kind of covered, let's go look at our algorithm again here, general algorithm. So we kind of covered, yeah, we pre-processed the video, kind of what we're doing here when we, that text file I was showing you guys as part of step 3 here, where we're averaging the pixels and we're essentially taking the average pixel for that frame. So that's taking all the pixels in the frame, averaging them together. Is it mostly white? Is it mostly not white? Is it red if we're having a red signal, you know, so on. But now we get into the more advanced issue. And before I kind of touched on this, but we run into a small issue with who's sending the message. Are they giving us the proper gaps between SOS and the word breaks, or are they just kind of sending the signal? Did they have like when they were doing their light, did their thumb slip? You know what I mean? Or did they program in 6 frames of gap or whatever? There's a billion different combinations for valid Morse. And for a human operator, it's no problem, right? You read it, you're like, oh, that's an S, that's an O. Okay, we're good to go. Um, but for the program, we need something a little bit more concrete. So what we use is we use k-means clustering to help solve this issue. And so what we do is we actually have two different classifiers. We have the on durations and the off durations. And here's the professional jargon. We have the on clusters, which measure dots and dashes, and we have the off durations, which are intersymbol, letter, and word gaps. So what this means for us, I'll just kind of give you guys a quick rundown here, is imagine that, so we have our on clusters, and for the on clusters, imagine you have a timeline, and this is a one-dimensional classifier, okay? So this is time, okay? And let's pull up a video here. When we have our hack the planet thing going here, when you have these lights blinking, you can see like there's a mixture of short and long, right? That's what Morse is. And so for each one of those light groupings, what we do is we say, okay, maybe we have one that was, it was just a little bit long, because remember the top axis is time. So maybe this one was like 2 seconds long. This one was like 3 seconds long. We had another one that was like 1.5 seconds. And then way over here, we had one that was, you know, 6 seconds. And so what we're doing is we're essentially plotting all of these. We aren't, but the scikit packages and things like that are plotting all of these, and they're dynamically splitting apart dots and dashes. And then for the off clusters, it's very similar. And this happens to do with, I think CyberChef will do our best bet showing this here. So when you have these dots and dashes, so a dot is an E, dash is a T, but together they're an A. Okay, so the question is, are you looking at an A, an E, or a T? And so we need to know the gap that is between two symbols could be, if it's intra-letter, then they're making the same letter together. These are part of the same letter. And then this gap that is between the A and the E is the letter gap. And then the longer gap, which is denoted as a slash in some forms of Morse, would be um, like a word gap. But see, again, you kind of have to have these gaps in here for the official Morse. So we're measuring this gap for the longest gap. We're measuring the letter gap for the middle, and then we're measuring the shortest gaps as saying, hey, that's part of the same letter. It's just multiple dots and dashes to make that letter. So what you end up with is a sort of a clustering where you have like, you got like a short, a medium, and a long. And so this is like k equals 3, still one dimensional, but this is k equals 2 and k equals 3. So that's kind of a long roundabout way, but long story short, we are using k-means clustering to account for timing variation across different clips from different operators, different equipment, noise, inconsistency, whatever. And that essentially, we can go through the code, but that has to do with grouping all of those into the on and off frames, doing our cluster durations for on and off, and then we have to map them back to dots, dashes, and what sort of word breaks we're talking about, letter breaks, interletters, things like that. After that, we get back to the normal stuff. So we construct the Morse symbols, and then just a straight decode. Let's take a quick look at the code here. It's pretty straightforward. I think we've covered most of the stuff. We open up with our license, free to use this however you want. It's really for me, for class, and so I can use it in CTFs and things like that. But we have our Morse dictionary. You can add custom things here too. Like if for some reason you think that it's like some combination of like custom Morse or whatever, go ahead and feel free to modify this dictionary. We have our output. We have a RGB tolerance. This has to do with sometimes when you have a video like this, like let's say that a bird flew by the window outside while I was recording, it might slightly change the color of this non-important detail down here. You know what I mean? We really care about the flashlight, but the ambient light could change. Like let's say someone, yeah, someone walks by, a bird flies by, whatever. That's what this RGB tolerance is. I found that 90 works for most of my use cases. Um, we'll hop down here. I guess I could just jump through these real quick. We have our pixel average. So that is what creates these right here. It takes some frame, that's important, after the frame has been filtered for all the data that isn't important. So like it pretty much just take like this data, maybe like the spikes of the star or whatever. It's going to simplify all or average all of those together into this. We have this extract frames, which takes the frames out, and yep, it actually saves everything that you need. Load frames is a helper function. Group frames and cluster lengths happen to do with essentially taking, let's see here, taking a grouping like this, and it says this is an on state, this is a light state, and then um, it takes the number of frames and it classifies it so it can be dumped into something like this one-dimensional graph here. Let's see here. We have our decode Morse, which actually takes all of the sorted stuff out, breaks it apart. Then we have our basic Morse to text converter, real straightforward. And then our main function with arg parser and things, pretty straightforward. There's really not a lot here. We're talking 200 lines of code, but I think at least for myself, oh, not even because you have the license, but I think at least for me, I can tell you I've spent at least a couple hours in various CTFs and things, sitting there with the video, slowing it down, marking on a pen and paper. So for future stuff, this really has only been tested with standard flashlight signals. Um, in various competitions, like at DEF CON 31 at the Snacky Machine, it was like a red blinking light. This hasn't been tested with that, but it would be nice to extend it. Mostly staying with one color should work pretty fine, I think. But like at Wild West 2025 in Denver, they had a Morse challenge that was using different, the carrier signal was green, and blue, green, and I'm sorry, blue, red, and cyan are the data signals. So this would be nice to extend to be able to handle multiple inputs like that, or like double encoded Morse where you're having like two data signals in one carrier, things like that. Some other improvements that I think could be made in the future. I'm not a data scientist by trade. Um, I followed this really great link, which I included at the bottom of the directory here. It is the, uh, I think they call it K-means clustering for dummies. Mm-hmm. Ready? Close down all this stuff. Um, they have their class up here, but then down here they get into like how you actually do k-means clustering with Python and things like that. Again, I'm not a data scientist, so it works okay, but I think that there's probably a better way to do this. So I'd be interested to hear your guys' thoughts. Um, and you know, it's cool having it as a it works, right? But I have to take a recording with my phone, then I have to move it to my laptop, AirDrop it, Discord transfer, whatever, and then run it. It'd be really nice if this was all just packaged into an app. Expo apps are really easy. If we have some more time, maybe we'll port it into an app so you can just record it, or maybe we'll add a flashlight feature too, so you can like send messages back and forth across a room to somebody. I think that'd be really cool. Um, but I think that's it for this week. So, kind of a basic tool. Should save some time. Again, we value any feedback, and thank you.